Hi everyone. Here question is conversion of epsilon NFA to DFA using subset construction method. As explained in the last video, there will be two steps to convert epsilon NFA to DFA. The first step will be finding out the epsilon closure of each state. Here how many states are there? States are 3 PQR. So in the first step we will be finding out epsilon closure of all these 3 steps. And in the second step, using subset construction method, we will be constructing DFA for the given epsilon NFA. So let's start. As there are 3 methods, this table will contain epsilon closure of all these 3 methods. Epsilon closure of any state is nothing but set of states including itself. So I am adding here including PQR itself, and then I will try to find out the epsilon closure. What's the epsilon closure of P? First, go to the P, add P in the epsilon closure, then find out is there any epsilon transition from P? There is transition for A, transition for B, C. There is no transition for epsilon from the P. So epsilon closure of P is only P. Epsilon closure of Q is first Q itself, then go to the state Q, try to find out epsilon transition. Yes, we have one epsilon transition, it's going to P, so add P here. Epsilon closure means what? To how many states or to whatever the state this corresponding state Q can reach using epsilon transition. Those states you need to add in the epsilon closure of Q. There is no any other transition from the Q for the epsilon. Similarly for R, add R state, then go to the R, find out epsilon transition. We have epsilon transition from R going to where? Q, so add Q. From Q we have epsilon transition going to P, so add P itself. There is no any other transition from R. So we got epsilon closure of all the states. Now second step. In the second step, we need to construct DFA using subset. So new subset gets created means new state will get created. But for the initial state, what we do? We just consider that whatever the starting state given in the epsilon NFA, for example P. So epsilon closure of the P, I will write here, let epsilon closure of P, that is nothing but P itself is new starting state. New starting state for what? For our DFA. So let's assume this and let's continue with the subset construction method. So P epsilon closure is P itself. It means what? Here will be our P state of our required DFA, and then as per this assumption, epsilon closure of starting state of epsilon NFA, that is what P, will be the starting state of our DFA. Then what we need to do? We need to find out transition. For example, transition function P, for which symbol? Symbol A, symbol B, then symbol C. So PA. How to find it out? Delta state P reading symbol A. Then how it is gets calculated? You need to write down epsilon closure of the same function, transition function here. Delta state P reading A. How to find it out? Write down this epsilon closure as it is. Then go to the existing or given epsilon NFA. Delta PA means what? State P reading A. Going to the state P reading A. It's going where? P only. So write it down P itself. Is there any transition for A from P? No. Then epsilon closure of P. What is it? P itself. What does this shows? This indicates that P is a state reading A. Going to where? Going to P. Means P having self loop for A. So P having self loop for A. Similarly, this is for symbol A. Now repeat for the symbol B. So just remove this A from here. Write down symbol B here. State P reading B. So go to the state P reading B, going to the state Q. Going to the state Q. Is there any other transition for B? No. So epsilon closure of Q, what is it? QP. So write down here QP. As I explained, here are the two states as it's a NFA. We are designing DFA, so QP will be considered as only one state. Don't get confused, these are the two states. This is the only one state. What does this indicate? P state reading B going to new state QP. You can consider as a QP, PQ, anything. Name of the state doesn't matter. I am writing here as it is QP. For which symbol? Symbol is B. Then similar process, write down here C. As there are three input symbols A, B, C, we have find transition for A and B. Now we'll be finding transition for C. So P reading C. So where it's going? Check the existing NFA, epsilon NFA, and based on that find out the transition. P having transition for C, going to where? R. Then epsilon closure of R, what is it? RQP. Then again, this is the only one state. Even though it's a NFA, it looks a different state. This is here only one state, RQP. It means P reading C going to new state RQP. So I'm writing here R, Q and P. For which symbol? Symbol is C. Now we find out transition for ABC from the state P. Now similarly, you need to repeat the process for all the remaining states. Remaining states means what? See, once we got new subset, like here QP is a new subset. So find out transition for ABC from the QP. Find out transition for ABC from the RQP. Repeat the process. How to repeat it? Same, delta. Initially we will take QP. Reading which symbol? For example, A. Write down this as it is here. QP. Reading which symbol? A. QP reading A. Then repeat the process. Epsilon closure, delta QP A. Here how to read this QP reading A? You need to go to the existing epsilon NFA. Then you can find it out. Q reading A. Go to the state Q. Reading A. It goes to Q itself. So write down Q here. Then P reading A. P reading A. It's going to P itself. Write down P here. Now epsilon closure of QP, you will say there is no QP, there is no epsilon closure of that. It means what? Epsilon closure of Q union or plus epsilon closure of P. What is epsilon closure of Q is? It's a QP. It's what? QP. And epsilon closure of P is what? P itself. So I can say union P. It is nothing but union means common only once. It is what? QP itself. It indicates that QP state reading A going to state QP. It's a self loop. So give here self loop for QP. Similarly, try to find out for other symbols. What is the other symbol? Other symbol is B. So state reading B, and where it's going that we need to find out. So QP reading B. Write it down as it is. QP reading B. So QP reading B means what? Q reading B. So this is the state Q reading B going to R. P reading B. P reading B going to state Q. Here you need to read like this. Transition function QP comma B. Q reading B go to the state Q. Reading B going to the R. P reading B. P reading B going to the state Q. So epsilon closure of RQ. It means what? Epsilon closure of R union epsilon closure Q. Epsilon closure of R. It is what? RQP. RQP union epsilon closure of Q. What is epsilon closure of Q is? It's a QP. So union QP. What is common here? QP. So take it only once. RQP. So delta QP on reading B means this state reading B going to where? RQP. We have this RQP on which symbol? Symbol is B. Similarly, try to find out for symbol C. Repeat the process. So QP state reading symbol C. So QP reading C. So write down here. So Q reading C. Go to the state Q. Q reading C. Is there any transition for C from the Q? No. There is no transition for C. Then P reading C. P reading C going to where? R. So I am writing here R. Epsilon closure of R is RQP. RQP. It means what? QP reading C going to the state RQP. So QP reading C going to state RQP. Now we are able to find out transition for ABC from the state QP. Now what is the new subset? New subset is RQP. So repeat the process for RQP. So transition function for RQP, let me write down here. Transition for RQP for symbol A, and find transition for the symbol A. RQP for symbol A. Then epsilon closure of R delta RQP comma A. It means what? R state reading A. R state reading A going to R itself. Q state reading A. Q state reading A going to Q itself. P state reading A going to P itself. So epsilon closure of RQP. Epsilon closure of RQP, it means what? Epsilon closure of R union epsilon closure of Q union epsilon closure of P. What is the epsilon closure of R? It's a RQP union epsilon closure of Q. It's what? QP. Epsilon closure of P. Epsilon closure of P. What is it? It's a P itself. So union P. What does union says? Take common only ones. So RQP union QP. QP is RQP. It means what? RQP on reading A going to itself. So there will be self loop. Repeat the process for another symbols like B and find out transition for B, where it goes. Same state RQP reading A. Sorry, for A we already find it out. So reading B. So where the transition of B goes for the state RQP. So check here, R reading B transition for R for B from state R, it is not given. Then Q reading B going to R itself. P reading B, it's going to Q itself, RQ. So all these three states, and we need to find transition for B. So if you go to the sim directly for R, there is no transition for B. Q, transition for B going to R, that we have written here. Transition for P reading B going to Q, that we have written here. Now repeat the process. Epsilon closure of RQ is nothing but epsilon closure of R union epsilon closure of Q. What is the epsilon closure for R? It's nothing but RQP union epsilon closure of Q. It's what? QP. What is the union says? Union gives the result RQP. It means what? Transition of RQP reading B going to the same state. So we have this self loop going to the same state. Now repeat the process for another symbol. Symbol is C. RQP state reading symbol C. What does it says? That we need to find it out. R reading C, Q reading C, P reading C. From each state reading C. So from P reading C going to R. So write down here R. Q reading C, there is no transition. P reading C, already we have written, and R reading C going to P. Initially it was reverse one. Actually R reading C going to P. You can write in any direction, doesn't matter. Finally we are taking the union. P reading C, it's going to R, and there is no transition from the Q. So it's a correct one, RP. Again, epsilon closure of RP is nothing but epsilon closure of R. What is it? RQP. Then epsilon closure of P. What is it? Union P. So RQP union P, it's nothing but RQP itself. It means what? State reading C going to itself. It's going to itself. ABC having the self loop. And this becomes our final DFA, as there is no new subset is created. And if you observe this, from P we have transition for ABC. From QP we have transition for A, B, C, and from RQP we have transition for ABC. If you want, you can rename these states as you can give any other name like Q0, Q1, Q2, and you can say this is the final DF. If you want to give nomenclature like that, we can give now also. You can redraw the structure like Q0 here, then Q1 here, and this is the Q2. What's the remaining here? Here R is a final state. So wherever R is present, that state you can give the final one. Here R was present, so you can make this Q2. Actually this step should be taken before renaming, but as we know, here was RQP, so that will be our final state Q2, and this becomes our final DFA. Thank you for watching.